Hello, welcome back to Decaf-Math ASMR, and welcome if you are new here. It has been a little while since I've managed to upload a video. I'm sorry about that. Thank you so much for your patience. I'm happy to be here now and to have you join me tonight. I thought that we could do something a little bit different. We are going to literally do some decaf and math. So I will be tapping on a few decaf related items while reading off part of a derivative table. So this is going to be hopefully relaxing. I hope you like the simple sounds and more traditional ASMR sounds. And if you happen to fall asleep, that's totally okay. This is intended to be a sleepy math video. And if you don't really enjoy ASMR, that's okay too. I wish you all the best. You've probably already clicked off of this video anyway, thinking it's really weird. But for the rest of us, I hope that this is nice and soothing. And I wish you a peaceful night's sleep. So let's get started with the derivatives. The derivative of a constant. The derivative of a constant number is 0. The derivative of a constant number is 0. So the derivative of 5 is 0. The derivative of pi to the power of e is 0. The derivative of negative 2 is 0. The derivative of any constant number is 0. The derivative of x to the power of a number n, x to the n, with respect to x, so x is the variable to the power of a number n, is n times x to the power of n minus 1. N times x to the power of n minus 1. I pull the power down in front, keep the x and raise it to 1 less than the original power. Nx to the n minus 1. So the power of x, the derivative of x to the power of 4 is 4x cubed. 4x to the power of 3, which is 1 less than 4. Excellent job. The derivative of e to the x is e to the x. The derivative of e to the x x itself, it stays the same. E to the x. E is our constant. X is our variable up in the exponent. The derivative is e to the x. If the base is anything other than e, let's say a, where a is just some other number, let's say 2 to the power of x, the derivative of a to the x is a to the x, so it stays the same, but then you also multiply by the natural log of a. The derivative of a to the x is a to the x times the natural log of a. So the derivative of e to the x is a special case because it stays e to the x times the natural log of e, which is just 1, so that goes away. So it just stays e to the x. But for any other number, you just multiply by the natural log of that base. The derivative of the natural log of x is 1 over x. The derivative of ln x is 1 over x. Nice job. Very good. On to some trig functions. Classic decaf, Folgers. I don't even really drink much coffee. Actually, I don't really drink coffee. Except when I want to pretend that I drink coffee, I drink decaf coffee. Decaf coffee. Classic decaf. Okay. The derivative of sine of x is cosine x. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of cosine x is negative sine x. The derivative of sine x is cosine x. The derivative of tangent x is secant squared x. The derivative of tangent x is secant squared x. So that's secant x and that whole thing squared. So then the derivative of cotangent x is negative cosecant squared x. So tangent, the derivative of tangent, secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant x is secant x tangent x. The derivative of secant x is secant x times tangent x. The derivative of cosecant x is negative cosecant x cotangent x. So cosecant and secant have this pattern, secant x, tangent x. The derivative of cosecant x is negative cosecant x cotangent x. And if you write these out, you might notice a pattern. Here's a little trick here to help you memorize. The trig functions with c's that start with c's, cosine, cosecant, cotangent, have derivatives that have a negative sign up front. So the derivative of cosine is negative sine. The derivative of cotangent is negative cosecant squared. And the derivative of cosecant with a C is negative cosecant cotangent. And you'll also notice that cosecant and cotangent are buddies, and tangent and secant are buddies. Just some fun little mnemonics there, in case you have to memorize this for a class or something. Next, let's go through 3 more commonly used derivatives of inverse trig functions. So the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. The derivative of inverse sine or arcsine is 1 over the square root of 1 minus x squared. So the square root of 1 minus x squared, that whole thing goes in the denominator. Apple, cranberry, apple, 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 cranberry. The derivative of inverse tangent is 1 over 1 plus x squared. And you'll see these two used in trig substitution. The derivative of inverse tangent or arctangent is 1 over 1 plus x squared, where x is my variable. And we're taking the derivative with respect to that single variable for now. And last but not least, the derivative of inverse secant is 1 over the absolute value of x times the square root of x squared minus 1. 1 over the absolute value of x times the square root of x squared minus 1, all in the denominator. So it's like the inverse sine, the arcsine, but it's the square root of x squared minus 1 rather than the square root of 1 minus x squared. And for the secant, the derivative of inverse secant is 1 over absolute value of x, so you still have an absolute value of x there, times the square root of x squared minus 1. And that's it for now. We have hyperbolic trig functions, but these are the more commonly used ones, I think, in a calculus class. If you happen to be taking calculus and you have used something that I haven't mentioned, if you happen to still be awake, feel free to let me know down in the comments, but these are the ones that I've seen the most. And I hope that you are very relaxed now, and I will see you around for more math very soon. We will probably dive back in to some more math tutorial or math practice style videos here doesn't matter, we're just playing around. And we'll continue to mix some ASMR and some math and do whatever we feel like. So thanks for joining me here in the Math Nook. And ironic, after all this decaf, I don't actually have hot water, but I'm gonna go get some. And cheers to you, and I'm sending you much, much love, and take